Alright, so today's going to be 10.1, which is going to be unions and intersections. So there is a lot of vocabulary to understand for this particular module. They're all listed here, and then we're going to build on the vocabulary as we go. But most of them are pretty intuitive concepts once you get the hang of them. So a universal set is basically a set of all the numbers that we can even consider in any of our sets. Okay? Now we've also been given set A, set B, and set C. The universal set is all those numbers combined, okay? Basically putting all those numbers into one set. An element indicates membership or belonging to of a set. So for example, the number 2 is an element of set A, but the number 2 is not an element of set C. Does everybody see that visually why that's the case? Okay. A subset is a set whose entire elements belong to another set. Do you see how A is a subset of B, but A is not a subset of set C? Can everybody see why that is? Okay. Intersection is where the sets overlap. So what they have in common. So when you see intersection, if you want to add a note, you can say in common. So you're looking for what the sets have in common. And union is where you're combining sets. Okay? That's where you're taking two sets and combining what they have. Don't worry about if they're in common or not. You're just combining them. So for example, we combine set A and C, and we get 1, 2, 4, and 5. Do you see the difference between the symbol for intersection and union? It's an upside down version of the other symbol. Okay. A complement are all the elements of the universal set not named in a set. So for example, the complement of A prime, or set A, is 1, 2, 3, and it could also be written those two other ways, okay? And an empty set is a set containing no elements, a set of nothing. So you're going to see empty set written two different ways, okay? You're going to see, well actually two different ways. You're going to see it as empty brackets or that 0 with the slash through it, okay? So complement can be written 3 ways, empty set can be written those 2 ways. So you can always reference this sheet as needed. Alright, so first thing we're going to look at is this sheet here. We're going to zoom in so you can take a look. We're going to talk about some real world scenarios dealing with set theory. So the first one we're looking at here is basically Oviedo High School math teachers. Is that a subset of all Oviedo High School teachers? True or false? Yep. True. Okay. Oviedo High School quarterbacks, is that a subset of the basketball team?
No.
False. Is Algebra 2 a subset of the OHS math courses?
I mean, if you're thinking about a subset of all math courses, because most high schools are not.
That's true. A subset can be, and this could be a subset of something else, as long as that one must be contained within that other one. So you could have a string of sets that are subsets of each other, right? Like we could go down to the point of, we could say cars. We could say cars made in, or cars manufactured by a Japanese company. We could have Toyota in there. Then we could have all the Toyota specific cars. Then we could do sedans. So you can really, go down the rabbit hole with this concept too. So let's look at this one here. So are the even numbers 0 through 10 a subset of numbers 0 through 10?
Yes.
Yes. Are all odd numbers part of the prime number set?
Nope.
No. Can you think of an odd number that's not a prime number?
11.
That's a prime number.
7.
Also a prime number.
21.
21, good. 21 is going to be an odd number that is not a prime number because it has a factor other than 1 in itself. So since you can think of one counterexample, it can't be the case, even if you can think of just one counterexample, okay? And then are OHS math courses an element of the Algebra 2 course set?
No.
Nope.
Very good, it would have to be the opposite. So you're going to see that sets don't go both ways and elements don't always go both ways. In fact, they rarely do. All right. So now we're going to deal with a numerical portion of set theory. So we are going to do an intersection and then a union. So intersection is what the sets have in common. What do these two sets have in common?
7, 8, and 9.
Good, 7, 8, 9. And the union is where we just combine what all the sets have. So we have a 5, a 6 from set A. Then we have a 7, 8, 9 that is in both sets. And then we have a 10 and 11. So when you combine sets, if any of the numbers overlap, you never write them twice. Okay? Everybody got that? All right. Next one. Where do these sets intersect?
None of the points or numbers.
Do they intersect at all?
Nope.
No, so it's just the empty set, which you can write one of two ways. And then union is where you combine the sets, which is going to become what?
1, 2, 3, 4, 5, 6.
Exactly. Any questions so far? All right, next one. Intersection. What do these sets have in common?
5 and 10. 5 and 10.
Good. And then if we merge them, basically find the union, that's everything that set B has,
5 and 20.
and then everything that set A has as well, which we already included the 5 and 10, so we only have to include the 15 and the 20. Does that make sense? Okay. All right. So now we're going to talk a little bit about Venn diagrams, okay? So how many of you in here have worked with a Venn diagram before? All right, so most of you have seen Venn diagrams, right? What's one of the contexts that you've seen a Venn diagram used?
There's like one area in the middle where both of them have something in common.
Exactly, yeah. So you maybe like in an English class, if you're comparing and contrasting something. You know, there's different examples where you may use it in a non-mathematical setting. And then we also use them in math settings. So I want to explain a little bit about how we use it in math and how it has to be very precise, unlike you might use it in other subjects. So the first type of Venn diagram we use is subset Venn diagram. With the Venn diagrams we use in math, we always have that rectangle on the outside that represents the universal set. So let me explain an example of that. Let's say the universal set is all the cars in the world, okay? And then set B, the one on the outside, is all cars that are Ford, okay? And then a subset of that would be all the Ford Focuses, right? Now, why is Ford Focus completely inside the subset of Ford?
Because it's a part of Ford. So
Yeah, is it ever, there's ever going to be a Ford Focus that's not a Ford?
no.
So do you see why that set is completely contained?
Ford's the only one.
Inside the other
Change
set.
engine to be a Honda engine.
Okay, well, it's still going to have the Ford, it's still going to be manufactured
It's
by
not gonna
Ford.
be a crappy Ford.
So, does anyone have any questions about the subset concept? Why there's no outside piece of A that's not in B? Okay. So this is a situation that's a little bit different. This is a union, okay? Let's say that we went down to the science building and we took a random class in the science building, and we took you guys and we put you all in the courtyard, okay? The universal set would be all the students in Oviedo High School, and then we took Russell's class and Miss Lee's class and put them all together. Okay, that would be the union of two sets, correct? Putting those two classes together, right? Now let's say we did the same thing, but we did intersection. We took all of the Oviedo High School students, we took my class, Miss Lee's class, and we put you together, but then we only took the students who have me and her as a teacher at the same time. That would be an intersection. Instead of just taking everybody, we're specifically taking the ones who have both of us as teachers, right? And then we'll talk about the complement. So we have the same set of students. We have the student body at Oviedo High School. We have my class and Miss Lee's class. Let's say we're going to take everybody in the school except for anybody who has you as a teacher. That's called the complement. It's taking everything except for one thing. Does that make sense? Okay, cool. So let's go ahead and make our own Venn diagram now that we have some conceptual understanding. So the first thing we're going to do is we're going to talk a little bit about what the universal set is. That's going to be represented out here with the U. Now I like to personally write out the numerical universal set. They wrote it out saying the universal set is set A and set B together. So what that means is it's basically just the union of A and B. So all the possibilities in either set, which are all the numbers listed. So that would be those numbers. So does anyone have any questions on how I got the universal set? Those are all the possibilities. Now we're going to finish our labeling our Venn diagram. So this circle on the left is going to represent A, and the circle on the right is going to represent B. This can be the case, but there doesn't happen to be one here. There's no elements in the universal set that are not in set A or set B. That can happen, but didn't happen right now. So nothing's going to go on the outside of the circles. Now for set A, what's going to go on this part of the circle on the left that's not overlapping? What numbers?
10, 11, 12.
10, 11, and 12. Good. What part of set A is going to go in the overlapping section?
13, 14, 15.
Very good. And lastly, what part is going to go in just the B section that's not overlapping?
All the rest
16
of
and
them.
17.
Very good, 16 and 17. So does anyone have any questions about how we wrote these numbers and why we wrote them where we did? Okay. Now we're going to go through and come up with some examples that they ask us. So the complement of A means everything in the universal set that's not in set A, which would be what numbers?
16 and 17.
Very good, 16 and 17. The complement of B is everything in the universal set that's not in set B, which would be?
10, 11, 12.
Very good. The intersection of A and B is what they have in common, which is?
13, 14, and 15.
I have a question.
Sure.
So why, for complement of A, is it just like a little apostrophe there, and then for complement of B, is it? Like
So do you remember on the page where I was explaining how there's 3 different notations for complement?
yeah.
So there's the little prime, there's the C, and the squiggle. They all mean the same thing.
Okay. Why isn't there just one to make it like so much less confusing?
Because math is confusing.
It's because mainly they were created in different places at different times, and then when you get into higher math, we use them in different ways. So they mean the same thing at this level, though. So now we're going to move on to D. Now I want you to look at D and E for a second. What is the main difference between D and E? Other than the letters used, like just by
Here's parentheses.
there's parentheses. So you all know how parentheses work in math. We have to work inside the parentheses first, right? Same thing goes here. So on this question, for example, you're going to take the intersection of A and B and then find the complement of that. So it's like a two-parter. Here you're going to find the complement of B, then put the union of them. So it just determines which direction you work, and it does affect the set. So it's really important that you recognize the difference. So here, we're going to find the complement of A intersection B, or B, basically A and B. Didn't we already find A and B? So now we're just finding the complement of that, which is everything in the universal set that's not here, which is what?
13, 14, 15.
No, 10, 11, 12.
There you go.
16, 17.
Oh, I wrote that. Yeah, I wrote that, and you were like, yeah, we already found A and B, so what's the complement of that?
Oh, it's
I
everything
see.
that's not the inter, okay.
Yes.
I thought you were
Excluding the intersection.
like, I thought you were talking about A and B, the question.
Oh, no, no, no.
It's not even.
So
So,
C
yeah, that
is
what I
basically
wrote.
we found the intersection of the two. Then we're saying everything that is not in the intersection.
Yeah,
Okay.
so I wrote that down first because I thought that's what it was. But then you were like, what's this?
Okay, so you got it now, though, so we're good. Okay. So this one here wants the union of the complement of B and A. So work smarter, not harder. Didn't we already find the complement of B in step B?
Mhm.
So all we have to do is take the union of this set right here and A. Union means that you merge them. So it's just going to be everything in A and in B. And it just so happens everything that's in A already includes everything that was already in B complement, correct? So I don't have to add anything additionally there.
But isn't it the complement of
Correct.
union
The complement of, no, it's the complement of B unioned with A. You do this first.
A? Okay, so that's kind of like a parentheses. It kind of just
Exactly.
I'm confused with that.
Okay. So, if there's no parentheses, you do each of these individually,
Okay.
and then you union them. If there's parentheses, you do this part first, then you complement them. Does that make sense?
So the union of B, which is or not union, the complement of B, which would be everyone's happy, so then just A.
Correct.
Union A. So it's just all of A.
So if it helps, like what I sometimes do, since we already had it listed, I didn't relist it again just for the sake of time, but like if it helps you with these questions, you can do it in two parts. you can list out what B is if you want right here. What B is not, rather. And then you can list out what A is.
Oh, so you're unioning, A and B, but you're taking out.
No. I'm finding the complement of B, and then I'm unioning the complement of B and A together.
Oh, I
Oh.
see, so alright.
Does that make sense now?
Yeah.
Okay.
So
Here,
this-
I was finding the intersection and then complementing it.
That is a
It's
little confusing.
It's only a little confusing because basically the complement of B is just what's only in A. And
Correct.
then you're combining it with A, which would be all the numbers
Yes.
of A.
Because in this particular situation, everything that's already in the complement of B is already in A, so nothing gets like double written, you know?
Right,
So it's
yeah.
all, yeah.
Okay, that makes sense.
Alright, so we're going to do another one like that. So this one we want to know the complement of A, which is this, right? We already found the complement of A earlier, so we don't have to do it again. And we're going to intersect that with original B. So what do these two have in common, these two sets?
16, 17.
16 and 17. Alright, you're starting to get the hang of it. Sometimes it just takes a little time. It's just like one of those things you sometimes just have to like think about a little bit as you work through them. But the home